We're trying to find the amount of active ingredient in aspirin. It's called acetylsalicylic acid. And as you can see in this experiment, it's very important to have eye protection. You will see why. The aspirin tablet was weighed. It was ground using this mortar and ground. And then after you grind it, you transfer it into a flask, a Lamaya flask. You add some ethanol, a good solvent, spin it for a while, and have here a magnet and a stirrer to aid in the dissolving process. Add some water, and then add 2 drops of the chemical indicator that will tell you when to stop the addition of the base. So we add a few drops, 1, 2, 3. The bivette has been washed with distilled water. The water was flushed out with some base, and then make sure that that this section of the bivette is filled. The tip should be filled with the liquid. There's no air bubbles. Take the initial reading. Use this reader. You place this mark behind the meniscus and take a reading. Okay, and then begin the addition of the base in a small increments. As you can see, the color appears and it will disappear again, will vanish, because we still have lots of aspirin left. Now the end point is the point when the pink color will last for about maybe 5 seconds. So continue to add, and near the end you have to add like small drops. So you hold the bivette like this and turn it, 1 full drop, 1 full turn. Okay, so you won't miss the end, because if you miss the end point, the trial is not useful. Okay, so again, okay, we're getting close now. Okay. It's very useful to have the, okay. So now, this is slightly over, but I was close enough. So at this point, you take the final reading of the bivette, and then subtract the final, initial from the final, to get the net amount that you have. Also, it's a good idea also to always rinse the flask. I think this color is reasonable on the dark side, but nevertheless it is okay. We do at least 2 trials, and this concludes the titration process. Okay. We're trying to find the active ingredient in aspirin, known as acetylsalicylic acid, by a technique called titration. Titration requires these items: a clean bivette, a ring stand to support the bivette, a Lamaya flask, a solution of a known concentration, in this case sodium hydroxide solution, and we're going to add the solution in a small increment to the aspirin, which has been dissolved in water and alcohol. And the end point is signaled by this organic indicator called phenolphthalein. Use a small amount. So we begin the stirring of the solution, and we add the base till the first appearance of a permanent pink color. Aspirin is given, the chemical formula is given right here, organic compound. It has a hydrogen, active hydrogen. We add the base, and the base will neutralize the acid to produce the sodium salt of the aspirin plus water. We call this neutralization reaction. Notice that the combining ratio is 1 mole and 1 mole, 1-to-1 ratio. We prefer to use the millimole. The millimole is a small quantity. So the reaction at the reaction endpoint, the millimoles of the base equals the millimoles of the aspirin. Millimoles. Now the millimoles of the base can be calculated by multiplying the volume of the base times its molarity. Okay? And this gives you the millimoles of the base, which is the same as the millimoles of the aspirin. Now once we have done that, then we can convert millimoles to milligrams by multiplying the millimoles by the molar mass of the aspirin, milligrams per millimole. Okay. So here's the calculations. The mass of the tablet was determined to be so many milligrams. The initial burette reading 14.7. The final reading is shown here. The net amount, subtracting these two values, 18.2 mLs of the base being used. Okay? So if you multiply the mLs by the molar mass, I obtained 2.04 millimoles of the base, the same as millimoles of the aspirin. And finally, milligrams obtained by multiplying the millimoles to the molar mass. So this is the amount I found to be 367 milligrams of aspirin. Remember now, the tablet itself weighed 375 milligrams, the tablet. The percentage of aspirin, divide the amount that you found by the mass of the aspirin tablet. So the tablet is mostly aspirin, quite high, 97.5% aspirin in a tablet. However, the company claims that the aspirin tablet contains only so much, while we obtained that much. There's some deviation here. So the difference between the two values, the claimed value and my value, came to be 42 milligrams. Therefore, the percent error, you divide this difference by the amount claimed by the vendor, 13%. Now, we need to know why is it that our value is higher than the claimed value. I suppose that the vendor does not want to claim something that's not true. They probably added more active ingredient than on the label itself, or perhaps some of these values are incorrect. Either the mass was incorrect, or maybe the molarity of the base was off. That's why we have to do 2 trials and then find the average of the 2 trials. Okay, and that concludes the determination of the active ingredient in aspirin. This technique, by the way, is used a lot in the industry, in a chemistry laboratory. You can find the amount of vitamin C in some kind of juice, how much vinegar is in vinegar, and so on. So it has lots of applications in chemistry. That concludes the experiment. Okay.